All right, 16C is mean and variance of a distribution. So the mean or the expected value, remember that is the exact same thing. The mean and the expected value, they're the same, of a discrete distribution can be given the symbol mu, which is mean, E of x, expected value, or if we are using a table, we often sum the xp of x row, and that would give us the expected value or the mean. Okay? The mean or expected value of a continuous distribution means that we're going to have to integrate because we don't have finite discrete points that we're going to be timesing together and being able to add up. We need to integrate x f of x. Okay, that's how we're going to find the mean of a continuous distribution between A and B. All right, going back to discrete data for a second, these are the formulas that we learnt in year 11. If the data is discrete, we know that standard deviation squared is the variance. We do have that other formula there, but that's a bit tricky to use. These ones here are the ones that we use in the tables. We find the x minus mu in brackets squared and we times that by the p of x, we sum that all up and we find our variance. Or we can also do it in this form. They were the two different forms that we had to find variance. Okay, that's kind of a recap of the past. I'm not going to be using those so much today because we want to talk about continuous data. Okay, so continuous for the expected value means that we integrate x f of x. If we want the standard deviation, we're going to be integrating x minus mu squared f of x. Or, here's your other one, integrating x squared f of x minus mu squared. So you can see that they are definitely coming from the discrete formulas, but we have to integrate them instead because it's on a continuous scale. All right, so questions. A chicken, here's our chicken wandering around the paddock again. A chicken is wandering randomly around a circular enclosure of radius 6 meters. It is just as likely to be in any one place in the enclosure as any other. Farmer Brown wants to know how far the chicken is from the water at the center O of the circle. We can approach this situation using cumulative frequency. Let f of x, capital F of x, be the probability that when Farmer Brown looks out, the chicken is no more than x meters from the center. This is also part of the question. We haven't had to do any work yet. So to find f of x, they've said that's the area of the inner circle over the area of the whole circle. That makes sense. Okay. The area of the inner circle is pi times x squared. We're calling that radius of the inner circle x, pi times x squared. The area of the outer or the whole circle is pi times 6 squared. And then to simplify the fraction down, you can cancel the pi's out. And so we just have x squared over 36, or they've written that with the 1 over 36 out the front times the x squared. Now it's saying that x has to be between 0 and 6 because that's the biggest, 6 is the largest that circle can get to. So it's giving it a finite domain that we're working between. But we know that f of x, little f of x, is the derivative of the cumulative function. Thus, the little f of x would be equal to, and it's already differentiated it for us, if you brought the 2 down, it would be 2 over 36, which is 1/18 x. Okay, that's all done for us, between 0 and 6. Okay, part A, we finally have to do something here. Find the chicken's mean or expected distance from the center. So in the theory that I just went through, I told you that the mean or the expected value of x, they're the same thing, is the integral, this is the formula, between a and b of x times f of x with respect to x. That's the formula, if you like to remember it as a formula. Okay, for my particular question, we are integrating between 0 and 6 because that was the domain that I was given. My x is going to be times with the f of x, this is lowercase f of x, which is the 1 over 18x dx. Okay, I'm going to put those together so that I can integrate it. So 0 over 6, I would have 1 over 18 x squared dx. Just timesing my x's together. Okay, integrating. Square brackets. Adding 1 to the power would make x to the power of 3. The 18 is on the bottom and I have to times that by another 3 because the power usually goes to the bottom as well. So 18 times 3 is 54 between 0 and 6. And then we sub in. It is 6 cubed over 54 minus 0 cubed over 54. Obviously, that's just equal to 0. 6 cubed over 54 is equal to 4. Good job. All right, so the expected place for that chicken to be is 4 centimetres from the, centimetres, whatever it was, whatever the units were, meters, sorry, meters from the centre of that circle. That's the average. Okay, let's keep going. Part B, find the standard deviation. There were 2 formulas for standard deviations. Why don't we do it twice so we can practice both formulas? You don't want to do it twice? Okay, you do want to do it twice. Okay, so let's divide it down here. The first formula that we had, go method 1, method 2. Obviously, you wouldn't do them both if you're in a test. You'd choose your favourite and go for it. Okay, so the first formula was sigma squared equals, should I write it down as a formula before I sub into it? Good, shouldn't I? I'll write it down as a formula first. So this one, I'm going to do between a and b of x squared f of x minus, or dx, sorry, minus mu squared. And this one is sigma squared equals between a and b x minus mu squared f of x dx. I reversed them from what's in the book, but that's okay. Okay, so they're the 2 formulas that we have. Let's use both of them. So the values that we have, we are going to be integrating between 0 and 6. X squared is just x squared. F of x is 1 over 18x dx. So that's the integral part. But then we have to subtract mu squared, which was the expected value that we just found, which was 4. So 4 squared. Okay, tidy it before you integrate it. Between 0 and 6, we have x cubed over 18 dx minus 16. All right, ready to integrate. Square brackets. Add 1 to the power is 4 times the power to the 18 on the bottom. 4 18s are 72. Between 0 and 6 minus 16. Okay, subbing in, we have 6 to the power of 4 over 72 minus 0 to the power of 4 over 72 minus 16. That 0 to the power of 4 is nothing. So you're typing in 6 to the power of 4 over 72 minus 16. It's 2, yes. Now that is not the standard deviation, that's the variance. If you want the standard deviation, so I'm going to say therefore standard deviation is equal to the square root of that, so square root of 2. Let's use the second formula just to prove that we can do it both ways. So the second formula, I'm integrating between 0 and 6. I need to do x minus the average, which was 4, bracket squared, times by f of x, which is 1 over 18x dx. Okay, I can't integrate it like that. I'm going to expand it so that I can integrate it. First of all, expand the the bracket, with the squared on it. So you're doing x times x is x squared. Double the middle would be negative 8x, and 4 times 4 is 16. That still has to all be multiplied by the 1 over 18x dx. Okay, we could take, just to make it tidier, let's take the 1 over 18 out to the front. Otherwise, I'm going to have big, horrible fractions in all of that thing that I'm about to integrate, which is okay. There's going to be fractions in there anyway. So you could do it that way if you wanted to. But I'm going to times the x with the others. So it's going to be x cubed minus 8x squared plus 16x dx. 4. Oh, it's a 6. Thank you. Yes, I think I was just copying that from the my bracket. That was meant to be a bracket there, and that's meant to be a 6. Thank you. Okay, integrating. We have x to the power of 4 over 4 minus x to the power of 3. That's not going to be nice. So over 3 plus 16x squared over 2 would be 8x squared between 0 and 6. And now we need to sub in still. So 1 over 18 out the front. We have 6 to the power of 4 over 4 minus 8 times 6 cubed over 3 plus 8 times 6 squared over, no, not over 2. Where'd that come from? Get rid of that. There we go. Now, do I need to sub in the 0? It would all just be 0, so I'll leave that bit off. Type that all in, and hopefully it equals 2 as well, because it's meant to. It does? Yeah, good. All right, so it equals 2 as well, which means my standard deviation is equal to root 2. Okay, so just goes to show you can use either formula. So you might have a preference that you lean towards one or the other. Question 2. We're basically going to do the same thing again. It says find the mean and the standard deviation of y equals 1 over x between 0 and 8. Mean and the standard deviation. So we've got the two different formulas that we've just looked at. The mean, or the expected value of x, is equal to the integral between a and b of x f of x dx. That's our formula. You don't have to write mean and expected value. I'm just trying to highlight it, but they're both the same thing. We are, this time, integrating between 0 and 8. And we have x times by f of x, which is 1 over 8. So this thing here, that is the same as little f of x. Okay, dx. So that would be x over 8, just putting it together, dx. And now I'm ready to integrate. So square brackets. Add 1 to the power would be x squared times the 2 to the bottom will be over 16. Between 0 and 8, sub in. So we have 8 squared over 16 minus 0 squared over 16, but that's just 0. So 8 squared over 16 happens to be 4 again. That was the same as the last question. It's not always 4, just so you know. Okay, let's do the standard deviation, which we're actually doing variance first. So standard deviation squared will be equal to, I'm going to choose this formula because I think it's normally shorter. Won't do both of them this time, there's not enough room. Okay, you could do the other one if you wanted to though. We're going to sub in. We are integrating between 0 and 8 of x squared times 1 over 8. I'm just going to put the 8 straight on the bottom. Dx minus mu squared, which is 4, so 4 squared. Integrating. Add 1 to the power, divide by the power, so 3 times 8 is 24, between 0 and 8, minus 16. And then sub your values in. 8 cubed over 24 minus 0. When I sub that in, it'll just be 0. And then minus the 16. Equals. I believe that is 16 over 3. Do you guys get the same thing? Okay, so therefore standard deviation, don't forget, you're not finished there. You've got to change it into standard deviation. So you need to square root the 16 over 3. If you're doing it in your calculator, it will rationalize the denominator for you, which is what you want, to get 4 root 3 over 3. Yeah? Well, those of you that don't have those calculators, you're squaring the 16 to get 4, so it'd be 4 over root 3, and then you'd have to times by root 3 over root 3. Okay, one more question, but it's doing the same thing again, so we should be really good at this. Find the mean and standard deviation of y equals 1 over 50x between 0 and 10. So this is going to be the f of x, little f of x. So the mean, or the expected value, whichever one you want to call it, is the integral between a and b of x f of x dx. We are integrating between 0 and 10 of x times 1 over 50x. So let's change that to be x squared over 50. I'm just saving myself a few lines here. Dx. Is that all right with everybody? Integrating. Add 1 to the power times that power to the bottom. So 3 50s is 150 between 0 and 10. Sub them in. We have 10 cubed over 150 minus 0 cubed, so that's just 0. And that is equal to either 20 over 3 or 6 2/3 if you prefer the mixed numeral. Probably prefer the 20 over 3, knowing that we have to use it to keep going. Okay, so now we need to use that to find our standard deviation. So variance squared, or standard deviation squared, sorry, sigma squared, is equal to between a and b of x squared f of x dx minus mu squared. Just like that formula for integrating, because it's not as much expanding and other stuff that you have to do. So for ours, we are between 0 and 10. X squared times the 1 over 50x will be x cubed over 50, just times them together straight away, minus mu squared, that's 20 over 3 that I'm going to square, so 400 over 9. I'll do that on the next line though. Integrate. Add 1 to the power, divide by the power. 4 times 50 makes 200 between 0 and 10. Then we're going to minus 20 squared is 400, 3 squared is 9. Square the top, square the bottom. Sub in 10 to the power of 4 over 200 minus 0, because 0 to the power of 4 over 200 is still 0, minus 400 over 9. Did you guys get an answer? Yes, I see nods. What did you get? 50 over 9, and you remembered to square root it to get standard deviation. So square root of 50 over 9 in rational denominator exact form is 5 root 2 over 3. Beautiful. It's not too bad.